Hi everyone, so today we're looking at finding the nth term of a sequence. So you might see a question like this where it asks you to find the nth term. My little tip is to first of all write your times tables, or the numbers that are the times tables. So first of all starting with the 1 times table, the 2 times table, the 3 times table, or if you do want to write this down, just remember it. Another way to write the 1 times table is just to write the letter n. Another way to write the 2 times table is to write the term 2n. 3n for the 3 times table. 4 times table would be 4n, and so on. It goes like that. So the times table is the number in front of n, and if you think about it, n is just consecutive numbers, 1, 2, 3, 4, 5, 6, 7. So 2 times 1, 2 times 2, 2 times 3, that's what the times table is. So this is why we can write it like this. Now this will help us when we find the nth term. So what we're going to do is we're going to look at our sequence and we're going to find the difference between each of the terms in the sequence. Difference being them taken away. So the difference between each term is the same. It is 3 all the way across, and it would carry on. Now another sequence that has a difference of 3 is the 3 times table, and what do we call that? We call that 3n. So we're going to write that down. The thing is that the 3 times table doesn't look like this. It looks like this. So 3, 6, 9, 12, and so on. So I'm writing the 3 times table above. And then what I'm going to do is I'm going to compare the numbers that we've got in the 3 times table to our sequence. So what do we have to do to get our sequence? We have to add 2. So we have to add 2 plus 2 plus 2. So that means I can confidently write 3n plus 2 would generate any term in my sequence because I've just looked at it comparing it to the times tables. Okay, and that's the final answer for that one. Okay, another question you might see is this. Is 205 a term in the sequence 1, 5, 9, 13 and so on? So what we're going to do first is we're going to find the nth term the same way we just did. So looking at this, we've got to find the difference. So the difference is 4. That means it's similar to the 4 times table. So let's write 4n as our starting point here. And then we're going to compare the 4 times table to our sequence of 4, 8, 12, 16, and so on. And what do we have to do? We have to take 3 away each time. So we can confidently say that the nth term is 4n minus 3. But that's not what it's asking us to do. It's asking us to see if this number is in the sequence. Well, if it's a number in the sequence, then n will be a whole number because n represents each place in the sequence. The first place, second place, third place, fourth place. So it can't be a half, it can't be a decimal basically. So 4n minus 3, if that's true, if 205 is in the sequence, then this will come out as a whole number. So we're going to solve, see if we can figure out if it's a whole number. So we're going to solve it. So we're just going to, as we would do, solve any other equation. Plus 3 to both sides, that gives us 4n equals 208. And then we're going to divide by 4 on both sides. So that's going to give us n is equal to 52. So that's a whole number. So the answer is yes, it is. It is in the sequence. Okay, one more question that you might get on sequences is something like this. So 5n plus 3, and it asks you to find, I don't know, the first 5 terms. So find the first, the 5 terms, the first 5 terms. So all you've got to do for this one is you've got to substitute in the values 1, 2, 3, 4 and 5 and then see what you get. So substitute the values. So substitute in 1 in first, so it would be 5 times 1 plus 3, which gives us 8, so that would be our first term. 5 times 2 plus 3, which gives us 13. And what you might start to notice now is the difference between the numbers is 5, and that's because it's the 5 times table, 5n. Okay, 5 times 3 plus 3 equals to 18. So I'm going to come up here. 5 times 4, put it in bracket, plus 3, which gives us 23. And then the last one, 5 times 5 plus 3, 28. So our sequence, just to write it out, is 8, 13, 18, 23, and 28. And that's it.